So today we're going to study the last part of geometry, which is 3D geometry. Okay, all the geometry we studied before that's about, plane, we call it plane geometry. It's a two-dimensional geometry. Right. 3D geometry, we're going to have two lessons. The first lesson may focus on cubes, rectangular boxes, okay? And the second lesson we'll study spheres, cylinders, cones. 3D geometry, it's a required material. I mean, I'm not sure you're going to study in the school, but this is a required by many countries. The reason I did not look at the textbooks that we are using in the middle school because they're all different textbooks. Okay, some private schools they're using a different, even more difficult textbooks. So what I did is I select these topics. I look at the past 20-year math competitions for the middle school kids, and then I look at what kind of topics is covered. Then based on that, I prepare my lectures. Okay, so I believe this is those are the material required. It's nationwide competition, so they know what topic should be covered, include. But different schools, so maybe they teach a different material. Okay, in my opinion, geometry is always the weakest, but algebra is always much better than any other subject, because most of textbooks, when you open it, you look at basically it's just algebra. Okay. Nothing, almost nothing else. Okay, that's the reason when I see the students in college, whenever they have problems using geometry, they're very weak. They cannot, number theory, maybe you don't use it. Probability, probably you're not going to use it. Suppose your major is engineering, but geometry will still be used. So engineering students at least should know geometry and algebra, right? To be successful in calculus courses, right? Like a mechanical engineering, definitely you have to dealing with the shapes, 3D shapes, right? Design the machines, parts, and without the geometry, you cannot do that, okay? But I find out the students, undergraduate students, even graduate students in the Department of Engineering, they're not good enough in geometry, so they have a trouble to finish the project. That's my conversation. I learned from the conversation with Dr. Shen in the Department of Mechanical Engineering. Okay, so let's begin with the base 3D picture. Okay, this is a rectangular box. Okay. Rectangular means all the angles are 90 degrees. Now, how do you draw? So this is the way we draw the picture, okay? So you have three sides, A and B and C. Oops, that's too small. Okay. Then what we should know, right? About for the cube, right? In the space, the three-dimensional space, you can talk about the total surface area, and you can talk about the length of the diagonal, space diagonal. Then you can also talk about the volume. The first time we have to introduce the volume. So let's begin with the volume. Volume, that's a definition, not a formula. The definition of volume is going to be the product of the three numbers. Okay, A times B times C. Okay, this is the definition. The first time the concept, we get a one dimension high, then you want to tell how much, right, space occupied of this solid. Then this is going to be yeah, just the product of those three numbers. Okay, but we already learned the area, right? The length. So for the box, what you can say, right? The surface area. Let's find the formula, right? So you have three pairs of identical faces. The front, back side, right? The front and back side will be AC, the area, and times 2. Then the left and the right, B, the right-hand side of the face it's a rectangle also, B times C. So B times C, but you have twice of that. Then the top one, the bottom one, the top one is also A and B, right? So it's 2AB, and the bottom one is AB. So that's the surface area. Now, how can I find the length of the diagonal? Okay, the length of diagonal in the space. Can I express that in terms of A and B and C? Yes or no, right? Yes, right? So the idea is to apply the Pythagorean theory to this. So how can I do that? I draw another diagonal at the bottom. Okay, then I get a vertical rectangle, triangle, right triangle. This is a right triangle. Okay, and this the length of the diagonal in the base is called x. Okay, so clearly d square is going to be x squared plus c squared. Okay, but x squared is diagonal of the triangle in the base, so x squared is going to be a squared plus b squared. So you get kind of formula, a 3D, formula of it's Pythagorean theory, 3-dimensional, right? D squared equals a squared plus b squared, c squared. So those are the formula, okay? And another important trick here is if, yeah. So look at the rectangular box, right? A, B, C is a product of three numbers. AC, BC, AB, they are the areas of each face, okay? So you will see that AC times BC times AB, okay, is a product of the areas of three faces. You end up with 2A, A squared, 2B, B squared, 2C squared, right? So this is going to be ABC squared. So the product of areas of the faces is going to be the square of the volume. Okay, is the square of the volume. And that's a very good point, because let's do the problem first. Okay, using the equation. Okay. 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 Here we have a 5, we have 3, and then we have 4 units, right? Now, if everything is given, then the volume is going to be, 3 times 4 times 5, it's a 60, right? The surface area is 2, and 5 times 3, and 3 times 4, and 4 times 5, okay? You multiply this out, you get 15 plus 12 plus 20. Let's do this computation. And 47. Okay? Then you multiply this out. It's 94. 94 square units. Okay. Now, if I did not tell you the dimension of each side, okay, instead I give you the surface area. And here's, I said 20 square centimeters. Here's 12 square centimeters. Then here's 15 square centimeters. Now, what is the volume? Okay. Of course, if you're lucky, if your brain works very fast, then you can figure out the edge length of each edge. Then you multiply them out, you get the volume. But that's not the purpose I want you to figure out. It's not easy. Sometimes impossible to write. Sometimes the edge lengths are very strange. Okay, it involve radicals, so it's not really good idea to. Yeah, it's still 60, but because you already remember, the previous picture, the edge length. Okay, so well, it's still possible. The answer cannot be determined. The reason is, how do you know the edge length can be uniquely determined? If edge length can be uniquely determined, I know there's one solution, 5, 3, 4, right? But do you think this is a unique solution or not in mathematics, right? If it's not, then the volume would be different, right? Suppose you don't know the above identity, AC, BC, AB equals ABC squared, okay? All right, to solve the problem, and you just write down all the possible products. A times C is 20, B times C is 12, right? And then A times B is going to be 15. You want to find out ABC, right? The volume, right? So you repeated this procedure. So you can try to find ABC and then multiply it out. We can do that later, okay? So we get A times C, B times C, and AB, right? That's going to be 20 times 12 times 15, okay? Then, but this side is going to be ABC squared. So if you multiply this out, it's not easy to find out the square, right? So volume is going to be ABC. We bypass finding each side. So it's going to be square root of 20, 12, and 15. Okay. Now, in order to get simplify this, we actually have to factor it. It's 4 times 5, and 3 times 4, and 3 times 5. And you will see that there's 2 5 there, 2 3 there, 2 4 there. That's a 4 times 3 times 5, and it's going to be 60. Okay, so this is another. Okay, then you can find the ABC. Okay, let's change the problem a little bit. This time because you already know the result. Okay, if you don't know the result, okay, if this is a 3 square centimeters, 2 square centimeters, and 1 square centimeter, okay, 1 square centimeters, find the volume, and each side. But this time each side is not the integer length. Okay, it's not going to be the integer length. So you have ABC, right? ABC. So step 1, you write down AC equals 3, BC equals 1, and AB equals 2. Okay. So now we multiply them out. AC, BC, and AB equals 1, 2, 3. Yeah, 3, 2, 1. Right, it's gonna be 6. Okay. So this side is still ABC squared is 6. So the volume equals ABC, which is square of 6. Okay, and you put the units here, cube unit, cube centimeters. All right, now can you find ABC. That's a question. That's an algebra question. Quickly. Mm. Okay. So yeah. Yeah. Okay. So this is the idea. Since you already find ABC, so you can use that combined with any of the equation, like A equals ABC over BC. Okay. And then ABC is the square of 6, BC is 1, so it's going to be square of 6. Okay, and the B is ABC over AC. ABC is square of 6, AC is going to be 3. Okay, and finally, and the C is going to be ABC over AB, and the square of 6, AB is 2. Okay, so this is a most quick way to find ABC. Okay. All right, so let's go back to the cubes. So cube is a little bit special, okay? All the sides are equal, right? All the sides are equal, A, B, right? All the sides are equal. So in that case, the volume is going to be A cube, right? And what is surface area? I think each face is going to be square, A square. But you have 6 faces there, so times 6. And the length of the diagonal, D, right? It's going to be A square, A square, A square, right? So D square equals A square plus A square plus A square. So it's going to be 3A square. So when you solve for D, you get square of 3 times A. Okay. All right, so let's look at the following problem. Okay, so a cube has surface area of 216 square centimeters. What is the volume? And this is just a two-step problem. You know, you're not given the age first. Okay, you're not given the age first. That's the easy problem. Okay, so the idea is, it's still same number, maybe, right? But it changes the cubic minutes. So you draw the picture. When you do the homework, okay, I want to repeat, let me repeat again. When you do the homework, you already print out the homework assignment. Don't just put a number there. You have to use a separate wide ruler paper. You don't need to copy the problem. You have to write down the problem number, okay? But for every geometry problem, you have to draw the picture, okay? So you draw the picture, you label it, okay? And then you write down what you're given. You say surface area 6A squared equals 216, right? Then you divide by 6. It's going to be 36. Okay, so 36. Okay, then you see A equals 6. Then the volume is going to be A cubed and 6 cubed, and they actually end up with the same number. Yeah, end up with the same number. Okay. And another problem is if you are given the length of the diagonal, you're trying to find the one, because the length of the diagonal uniquely determine, uniquely determine the edge length, say, of the cube. Then you can determine the volume. But I'm going to ask you to do the next problem. We want to, the surface area of a cube is 72 square feet. What is the length of the diagonal? Right? Yeah, what is the length of the diagonal? Okay, you draw the picture again, and then you write down the formula, right? Okay, and what you're given is, you're given 6a squared is going to be 72. Okay? So how do you solve that? A squared equals 72 divided by 6 is going to be, this is going to be 12. Right? A squared is 12, so you have to solve for A. Okay? You have to solve for A. So A is going to be square root of 12, which is 4 times 3, and it's 2 square root of 3, right? So that is A. Now, how do you get, how do you get the 2 times square root of 6? So D is going to be square root of 3 times A, right? Square root of 3 times 2 square root of 3, that's going to be 2 times 6.
No, 2 times 3.
2 times 3, it's a 6, yes. Okay? It's a 6. Okay, another problem, okay, here's the point. Okay, we draw this cube, right? This is a cube. It's a 5 by 5 cube. Okay, and I'm going to paint it first. I'm going to paint. I hope you remember this. You did a similar. I paint all the faces, okay? I paint. Okay, painted. All right, so now I'm going to cut it. 1, 2, 3. Okay. Oh, I see. All right, so a little bit. How many? 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. Come on. Yeah, okay, so got it. So we also have all right, so this is a box. It's going to be cut into many, evenly into 125 Yeah, it's cut into 125, which is a 5 cube. This many 1 by 1 by 1 unit cubes. Okay, so you got so many little cubes. Okay, so my question is, what is total area of unpainted faces? All those small cubes. This unit cubes. Okay, there are some faces are painted, some are complete unpainted. Okay, if it's coming from the inside, it's not painted. If it's coming from the corner, okay, then three sides, even 3 sides are painted. Okay, so you get 125 because there's a 5 by 5 by 5. 125 unit cubes, and then I just wanted to count those unpainted faces. That also gives you the total area of unpainted faces because those are unit cubes. Because this is a previous math competition problem. The cubes inside of this large cube, right, would be unpainted, all the sides unpainted. But if those are all sides, only one face or 2 faces, maximum 3 faces are painted, because if it's coming from the corner, the vertex of this large cube. Okay, Edward says 1,350. I think it would be a much smaller number. Edward. I'm talking about unpainted faces. Right? How about you? Huh? You haven't figured out? Oh, Charles Dean, you only get 39. That's really strange. Use common sense, okay? Definitely more than 39. Yes. Now, 288? All right. 588. You see, we do have different answers. So let's count how to count them. So you cannot just focus on this unit cubes. Otherwise, it takes forever to count them. You have to group them in 4 different categories. Like those cubes, all the faces are painted. Those cubes, 1 face are painted. Those cubes, 2 faces are painted. Something like that. But so the best way to do is, I count the total surface area of all those 125 cubes. So each little cube, 6 faces there. So 6 times 1 square. That is the total surface area. And that is the surface area of each unit cube. And it times 125. So that is total, including those faces are painted. But those painted faces, they all come from the large cube. So that's why in order to delete those painted faces, you just go back to the larger cube. The larger cube, that larger cube is 6 times 5 square because you have 6 larger faces there. Each face is 5 square. So if you take this difference, I think this is going to be, this is going to be 600. Yeah, it's going to be 600 because 6 times 125 is going to be 750 minus 150 is 50, it's going to be 600. Okay, so there'll be 600 unpainted faces because each face's area is 1 square unit. Okay, so this is the idea. You have this is the quickest way to solve the problem. Don't focus on each individual cube. Okay, you have to go back to count the paint. Use a subtraction. Sometimes help you to solve the problem. Subtraction. You find the surface area of painted faces. Okay, painted faces. Then you don't need to count them. You just go back to the original one. Then it's easy to count. Okay, so in order to find the total area of unpainted faces, you just need to find the total area of the painted faces. But painted faces is much easier to count. That's it. Much easier to count. Okay. My another question is, I'm going to, so this is a larger cube, okay? This is a cube. It's n by n by n, n by n. Yeah, this larger cube, okay? So the idea is that I'm going to cut them into n cube. Smaller cubes, okay? Okay, smaller cubes. And my question is, if the total surface area of small cubes is 5 times the surface area of the larger cube, what is it? Total Okay, so the idea is this. In order to increase the total surface area, you have to cut it into smaller cubes. Okay, that's why in the field, you will see tiny bit of small balls or small cubes inside, in the microscope, the material. We do not use a larger balls or larger cubes as a field material. Okay, because why? We want to increase the total surface area, so have more surface area contact with the water. Okay, so when you cut the larger cube, then into smaller cubes, you increase the total surface area. But what is not increased is the volume. The volume remains unchanged, but the surface area increased. That's why you want to make material as small as possible. If you dump it into the water, right, it's like a cube. For the coffee, the larger one takes too much longer time to dissolve in the water, in the coffee, because the surface area is smaller. But if you cut into smaller pieces, it's much quicker because it increases the surface area. So there is more contact with the water, more surface area contact with the water, right? So yeah, let's work out this problem. Okay, so you have to count. Yes, 150. N equals 150.
Not in the surface area of one.
I just want to find the n.
N is 5.
N is 5. Yes. Yeah, you don't know the exact size yet. Okay, so this is a cube, right? And this is a smaller one. Okay, let's assume the larger one, the smaller one is the edge length is a, right? And larger one here is n times a, n times a, n times a, because you have n, you cut them into n pieces. You can do this one. Okay, so the surface area here is 6 times na squared. Okay, that's the original one. And here you will get 6 times a squared. That's the surface area each smaller cube. But you have how many? You have n cubes there. Okay, so that is total surface area. It will be increased, as you can see that. Okay, so after you simplify, here you get 6a squared times n squared. Here 6. Wait a minute. Yeah, there's no square there. Okay, so 6a squared and cube. So the more surface area right now, but it should be, if it's equal to 5 times that, then you can get n cubed. It's a 5 times 6a squared n squared. Now you simplify this, then n cubed equals 5 times m, so n must be equal to 5. Okay, so that's a 5. Just needed to know how to calculate the surface area. Okay. Okay. My another question is, if you have a rectangular prism, okay, you have all the edges here. Okay. We know that the length of the diagonal is going to be square root of 14. And we also know that the length of all edges is going to be 24. Okay? Can you determine the surface area? Okay? So we are given the one-dimensional data, the length of the diagonal, right? And also I measure all the edges. I find out all the edges, the total length of all the edges is going to be 24 units. Can we determine the surface area? So to solve this problem, you should write down what we are given. Here's A and the B and the C. We are given how to find the total edge length, right? Like a pyramid. You have 4 identical edges. Total edges will be 12, I think. Okay, so will be 4A, 4B, 4C. This is supposed to be 24. Okay, this will become an algebraic problem. Okay, and then A squared plus B squared plus C squared equals 14. Okay, what do we want to find out? We want to find the A twice of AB, BC, CA. So this becomes algebra problems, right? You label each side A, B, C, and write down the given information. 4A, 4B, 4C equals 24, because that gives you total length of all the edges. And then A squared plus B squared plus C squared equals 14. That is gives you the length of the diagonal. Using those two equations, you cannot uniquely determine A, B, C. Clear? Because two equations, three variables, you're not able to do it. But you're still able to determine the area, A times B, B times C, C times A. There are a couple ways to do. One is, since you know you cannot uniquely determine, maybe you can let C to be 1. Then you try to determine A and B. Okay? Then that's okay. You get special values. And then you plug them into the area formula. Then you get the answer. Because the answer should be really independent. You know, yeah, you can have multiple solutions for A, B, C, but you can always get the same area. Okay? So there are a couple ways to do. So let's simplify the above equation. A plus B plus C is going to be 6, right? And A squared plus B squared is 14, okay? You cannot find the ABC in general, but you can find a special solution, ABC, okay? Then you can use that to find the surface area, okay? So you can assume a C. Yeah, what it can do. Yeah, you can assume C equals 1. You can assume C equals 2, right? 2, then A squared plus B squared will be 10. So what I want to do is give you the following identity. A plus B plus C squared is going to be, if we expand it, okay? Can you expand it? There's 3 terms here. Okay? If you don't know, you can do step by step. This considers this 2 as a 1 variable, and the 2 A plus B C and plus C squared. Okay? Then you get A squared plus B squared plus 2AB, and here 2AC, 2BC, and C squared. So you have these 3 together. This is the important identity. Okay? So now this gives you the surface area. Then, so 6 squared equals 14 plus 8. Then A is going to be 36 minus 14, and that is going to be 22. And this is a quick way to do it. Yeah, 22. Now, is there any way, I just say, you can find the special solutions? You still can find it. Then you find, yeah, let's see to be 2. You can, let's look at this problem, okay? If you don't know that formula, above formula, that is 6 A squared plus B squared equals C squared. It's a 14, right? So you can let C to be 2, okay? If C2 is then A plus B equals 4, A squared plus B squared equals 10. Now you only have 2 variables. Then you try to find the A and the B, but still you have to use the equation A. Yeah, I don't think it's simplified. You have to use the quadratic equation and find the A and the B. A, B are not the integers, okay? And what is the best way to get this? Well, you can assume A is the larger than B, so it's A squared plus B squared minus 2AB. Okay, and from here is 10 minus 2 times this. No, that's not good enough. Yeah, well, you have to, the best way to do here is you can use the quadratic equation to find A and B. Okay, for example, A squared, B is going to be 4 minus A squared and equals 10, blah, 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 blah. You can find A and B, but that's not the best way to do it, so I'm not going to waste time. Okay, so using the above formula, you can quickly solve the problem. Now, next one. All right, so the next topic I want to talk about is called cylinder. Okay, cylinder, we have a different type of cylinders. First of all, what's the definition of cylinder? Second, what is the so-called circular cylinder, triangular cylinder, and the rectangular cylinder? Rectangular cylinder is just the box, okay? So cylinder is defined in the following way. You can have a cross-section, but then this must be, it's not necessarily vertical, okay? So this two must be parallel, okay? Then the cross-section must be the same cross-section, horizontal cross-section. So this is called a cylinder, okay? It's not necessary to be a circle, okay? Now, the important, so this is the cross-section, the parallel cross-sections must have the same, must be identical, okay? I should say that parallel cross-sections are identical, okay? So this is in the most general definition of the cylinder. And the circular cylinder could be like this. All the circles, this is called a circular cylinder. Okay, it's still not a vertical. It could be shifted a little bit, like the Pisa Tower, right? You know, in Italy. Okay, so the question is, what is the volume? Okay, the volume formula is the volume formula for the cylinder is always the area times h. This is the h. Okay, not the real h. The height. Okay, h is the height, and a is the area of the base or the cross section. Doesn't matter. The base area. Okay, so when you the volume does not change when you slide on the, suppose you have two pieces, two parallel glass, okay? Two parallel glass, and then you have a fixed circle, right? Then you have another one here, then you draw the, okay? And you can move around on the top one. So this is two are parallel. Now what is unchanged is the height, the distance between those two glass. Okay, the distance between those two glass and the circle is not changed, but you can move it to here. Okay, mathematics shows that those two have the same volume, but other one is longer because it's shift. But then the volume remains unchanged. Okay, the volume remains unchanged as long as the cross section. This is a phenomenon similar to the triangle. You see, remember, triangle, if two lines are parallel, this is a triangle, right? But this triangle much longer, looks like it has more area. But because the base and the height is the same, so the area is going to be b times h. It does not change. Okay, as long as those two lines are parallel, no matter how long this triangle, the height is the same height. So the formula tells you you're not going to get more area. And the same problem here, you're not going to get more volume. Okay. So, but the most of the cylinders we are talking about they're perpendicular to the cross section. Okay, not shifted. But I want to know that because sometimes the problems will be, it's not a, the cylinder could be have a slope. It's not necessarily to be like this. Okay, so let's look at the circle, the right circular cylinder. Okay, the right circular cylinder is the most popular one. We usually call cylinder means like a cylinder. Okay, so it has. So the radius is r, and here's h. This is a 90 degree. Okay, perpendicular. Right, it's a 90 degree. So this is a 90 degree. It's perpendicular. It's called the right circular cylinder. Now, can you write down the volume formula in terms of H and R? Can you write down the surface area of the cylinder, including the top and the bottom? Yeah, surface area including top and bottom. That's more different. Huh? Volume is what? Yeah, the volume formula. Right. Give me the volume formula.
We learned this in school.
No, you derive the formula, okay, based on the one I just gave you. The volume formula is A times H, okay? Just need to know the cross section, the area cross section is the disk, yes. Yeah, so the surface area, first of all, the surface of the top one, the first one, the bottom one, pi r squared, but you have top and bottom, so you have twice of that, right? Now the side, how do you do that? The side is you cut the cylinder, you open it, and then you open it, you get a very long piece. So this side is the h. The circumference is 2 pi r. So becomes the length of this rectangle. So that's the reason it's going to be 2 pi r h. Okay? 2 pi r h. So that is the volume. This is yeah. Okay. My next question is. Okay, my next question is. A cylinder. This is a special cylinder, right? It's called a rectangular cylinder. It's box, okay? It's a square base. square base. Okay. Now inside this, I have a cylinder in square bit. Okay. A cylinder very tightly in square bit. My question is, what is the ratio of their volume? The volume of the cylinder over the volume of the box. Okay, this is a rectangle. Yeah, the height is not given, the radius is not given. Okay, but you should be able to calculate the volume. You know what percentage of the solid, right? Of the box is going to be occupied by the cylinder. Yes. Pi over 4. So Edward says pi over 4. Anybody else? Sophia says pi over 4. Right? Are you sure? 100%. Okay. All right. So to solve this problem, you know, you measure the radius, right? R, and here's the H, and the edge length. Edge length actually is 2R. Okay. So just the calculation, cylinder pi R square H. The box, the base area is 2R times 2, right? Square, and the H is here. So the base area times the height gives us the volume of this. Okay, then you cancel it, okay, and you simplify a little bit. You find that everything will be canceled out. So we pi over 4. This number is smaller than 1. Okay, so this example tells you that you should know how to name the variables, and then at the very beginning, you just pretend that you know all the dimensions. Then you simplify it. If you cannot cancel some terms, that means this cannot be uniquely determined. Okay, this cannot be uniquely determined. Yes. So if you haven't got this number, and next one will be you can look at. Okay, suppose you have yeah, let me. Okay, so I have a cylinder, 2 cylinder. This cylinder, the diameter equals the height. D equals height, okay? And another cylinder, I'm going to double the diameter. So it's 2D. But I shrink the height. It'll be half of H, okay? So can you say which one has a larger volume? Which one has larger one?
Yeah.
The one is short.
It's shorter.
Yeah. So the volume here on the left side, the volume is going to be this is going to be pi, right? And half of d squared and h. Okay. You can calculate that. It's going to be a quarter of pi d squared h. Okay. Then the other one, the one this is on the left hand side, the one on the right hand side is going to be pi times d squared because radius is d here, and this will be half of h. So the answer will be half of pi d squared h. Okay. So the other one must be larger. Okay. Now, of course, in advanced mathematics, there was a problem you have to solve. We're not going to discuss here. Is suppose you design a water heater for the company, right? That's all cylinder type, right? So you want to have a fixed 50 gallons water heater. So that means the volume is fixed. Then the boss asks you, can you design a cylinder which have a minimal surface area? Why have to solve that? Because more surface area have to use more material, right? If you only make one, that's okay. If you make thousands, then that's a lot more waste. Okay, so this is some mathematical problems. You can design what is the base to ship. Okay, of course later on they find out, oops, you cannot do that because then this is too big. So for the same volume, too big means the diameter is too large. There's no space you can put there. Okay, but then you can have two type of cylinders. If you have a limited space in your basement, then use this. You have to pay more money. You make more slim one. The ideal shape should be the diameter equals the height. Okay, but then if you have enough space, it's easy to carry around, then use that one. That saves me $100 for them. So there are many similar problems like that you have to deal with in geometry. Okay. So yeah, let's do the next one. Yeah, I have a cylinder. Okay, this is like a tree. Okay, so you're going to have yeah, I'm going to. There was a inscribed square base. Okay. So what do we have here? Yeah. So here's a question. So if I know, if we can get, yeah, what I know is this is a 2, that's 1 and the 1. Can you find the volume of the cylinder? Okay, so this is I know the dimension of the rectangular box inscribed in the cylinder. The height is 2 units. The edge length of the square is 1 unit. Okay, and can you figure out the volume of the cylinder? Yes. You have an answer?
Yeah, pi.
Pi? Any different answers? Hmm? All right. So all I have to do is actually reduce to the problem circle. Okay. So you have a square. You need to find the radius. Because this is one, this is one, and you draw it, and this is R. Okay. So R square plus R square equals 1 square. So R square equals 1/2. That's all you need to know. You don't need to solve for R, okay? So you figure out the radius. Once you figure out radius, then you know the volume, right? The volume of the cylinder is going to be pi R squared times H. So R squared is going to be 1/2. H is 2. That's easy, right? Yeah, that is easy. All right, so the next question. All right, so the next type of cylinder will be, we call the triangular cylinder, okay? Triangle cylinder, the cross section is a triangle. Okay, this is also called cylinder. Okay, you can call it different names, okay? So the same problem here, if the areas, the cross section is gonna be A, right? The triangle, the areas is A, then H is height, the volume is still equal to A times height. So then it depends on how do you calculate the volume, right? Okay. Yes. Okay. So now I'm going to ask you to do the following. Okay. We have, I hope you still remember, right? This is the triangle is an isosceles triangle. So let me draw the, okay. This is a, no, equated triangle. Equated triangle, okay? So I have a cylinder inscribed in this. Okay. Yeah, can you find the ratio of their volume? Again. Okay. Yeah. So the key point is you have to actually the ratio of their volume is reduced to the ratio of the area of the circle and the area of the equated triangle. Okay. So this is the equated triangle, right? Okay. Why? Because the ratio of the volume, this is the volume of the cylinder, right? This is the volume of the circular cylinder. This is a volume of the triangular cylinder. Okay, and then because the volume is going to be the area of the circular cylinder, right? Times the same height. So this is a circular cylinder, I call C. This is a triangular cylinder. Yeah, just AT. Okay, so HH canceled out. You just need to give me the ratio of the area, right? Area is a cross section. So here's the, if this is A, and A, that's radius R. So the question is, what is the formula for the area of the equated triangle? It's going to be square root of 3 over 4A squared. What is the area of the circle? It's pi R squared. So the question is, what is R over A? Right? Yeah, do you remember the formula for the area of the equated triangle? This is I just memorized it, but you can derive it by yourself. Okay, the reason this is A, this is A, here's A. This is going to be the special triangle, and that's going to be square root of 3 over 2 times A. So the base times height divided by 2 gives you the area formula of the equated triangle. So we learned the circles, right? And we learned the circles and the triangles. And how do you find the? Yeah, you have to find the R over A. Can you find the R over A? Yes.
Pi over 3 times the square root of 3.
Pi over.
That's for the cylinder.
Circular cylinder over.
Ratio of the
Yeah. So what is R over A? Right? Are you working on the problem? Kevin? No idea? All right, let me draw the picture. How do we get this? So this is a circle inscribed in a triangle, right? The best way to do is to use the area. So the area of the triangle is going to be square root of 3 over 4A squared, right? That's total. But this consists of 3 triangles. Yeah, this consists of 3 triangles. It's gonna be half A times R. But you multiply by 3 because the 3 identical triangles. Each of them looks like that. All right? Consists of 3 triangles. So multiply by 3, you get this. Then you get the identity, right? So square root of 3 over A and 3 to A times R. So cancel A. So I get R over A is going to be square root of 3 over 2 and 2 over 3 cancel. And so square root of 3 over 6. Okay? So R over A is the square root of 3 over 6. Then you plug them into the above formula, the ratio of the area of volume is going to be, let's go back to the, we have to finish the answer, right? It's pi over square root of 3 over 4, then R over A squared. Okay? Then you simplify it. So it's A over R, right? R over A is going to be square root of 3. And here's 36. Okay? So I'm going to simplify. And that thing is going to be 9. 36. So this will be the answer. Okay? Okay, so we stop here. I have